All right, here we go. We were looking at the 2018 AB free response, question number 4. That means that since it's question number 4, that this is calculator inactive. So here we go. It's a long one. The height of a tree at time t is given by a twice differentiable function h. I'm not even sure if that's going to be important, but usually if the college board tells you something like that, it's going to be important. So I'm going to underline it. Where h is measured in meters, so we've got units, and t is measured in years. Okay? Selected values of h of t are given in the table above. Okay, so h is twice differentiable, h is measured in meters, t is measured in years, and we've got some data points. Okay. In part A, we're asked to use the data in the table to estimate h prime of 6. Using correct units, explain the meaning of h prime of 6 in the context of this problem. Okay. H prime of 6, what do I know? I know that they're asking me to find the derivative of the function h at time 6. And so if I had a function, if I had an equation for h, I could find its derivative and evaluate at 6. Well, I don't have that. What I have is I have different points on the graph of h. And a common thing that we do in AP Calc, and I would expect it's going to show up on your free response exam as well, is that you're asked to approximate or to estimate the value of the derivative, slope of the tangent line at one point. And what you're going to have to do is use two other points on the curve that are close to 6 that you're going to use to find the slope of the secant line. So if I look at my table of values, I have t equals 5 and t equals 7, and I have the corresponding heights. So the derivative of h at 6 is approximately what I get by looking at the slope of the secant line that connects the 2 points. So this is slope of tangent. We're approximating with slope of secant. H of 7 is 11. H of 5 is 6. Over 7 minus 5 is 2. We get 5 over 2. That's our approximate or our approximation for the value of the derivative at time t equals 6. What does it mean? I would say at t equals 6 years, well, what does h measure? H is the height of the tree. So h prime is, at t equals 6 years, the height of the tree. Be specific. What's the height of the tree doing? The derivative is 5 over 2, which is positive. The height of the tree is increasing at a rate of 5 over 2. Now get me the units. What are the units in the numerator? Meters. What are the units in the denominator? Years. At t equals 6 years, the height of the tree is increasing at a rate of 5 over 2 meters per year. Gotcha. Perfect. Okay, so the College Board awarded 1 point for your estimate and 1 point for your interpretation, which had to include the appropriate units. So that is going to be 2 points for part A. Pretty typical question for the College Board to ask. Let's look at part B. In part B, explain why there must be at least one time t for the time interval 2 less than t less than 10 such that h prime of t is equal to 2. Why does it have to be true that h prime of t equals 2 for some point on the interval 2 less than t less than 10? Well, great question. And here's where you need to stop and think about the kind of question or the format of the question. They're asking you to show that the derivative has to have a particular value at some time on a given interval That is a very typical setup for the mean value theorem. That is what the mean value theorem tells us if certain conditions have been met. The conditions that we need in order to use the mean value theorem, we need h to be differentiable on some open interval a, b, and h to be continuous on the closed interval a, b. And if we have both of those things, then what we know is that h prime is equal to h of b minus h of a over b minus a at some point on this interval. We won't necessarily know where the derivative has this particular value, but that it must have this value. Okay, so what we're looking for is for this guy here, this slope of secant line, to be equal to 2. What we're going to have to do is we're going to have to look at our table of values to see if the slope of the secant line is equal to 2 anywhere. Now, normally where I would start, because they said on the time interval 2 to 10, I would say something like h is twice differentiable on the interval, what was the time, twice differentiable function h. H is twice differentiable, which means that h prime is differentiable and continuous. You can only be twice differentiable if you are differentiable, and then you also have to be continuous if you're differentiable, which implies that MVT applies. That has to be true. Great, now we've got to find the just right interval so that the slope is 2. We're going to have to look at the table of values, and let's see. If I go with the big interval from 2 to 10, 15 minus 1.5 is 13.5, divided by 10 minus 2, well, 13.5 divided by 8, that's not 2. Let's try small intervals. What about from 2 to 3? 2 minus 1.5 is 0.5. 3 minus 2 is 1. 0.5 divided by 1 is not 2. 6 minus 2 is 4. 5 minus 3 is 2. 4 divided by 2 is 2. That's the interval. So the way I would write that is I would say h of 5 minus h of 3 divided by 5 minus 3 is equal to 6 minus 2 over 2, which equals 2. Therefore, by the MVT, h prime of t equals 2 at least once on the interval 3, 5. The interval 3, 5 is inside the interval 2, 10, so I've done what you asked me to do. The way they awarded the points, they said 1 point for finding the slope, h5 minus h of 3 over 5 minus 3, and then your conclusion using the mean value theorem. Now, I'm pretty sure that if you didn't stop to indicate that the conditions for the MVT have been met, that you wouldn't be awarded the point. That's pretty typical with the College Board. If you want to use one of these named theorems, you have to make sure that the conditions have been met. So that's part B. Let's look at part C. In part C, it says use a trapezoidal sum with the 4 subintervals indicated by the data in the table to approximate the average height of the tree, on the time interval 2 to 10. So average height of tree on the interval 2 to 10. Well, one of the calculus things that you need to know is that the average value of a function can be found by calculating 1 over b minus a, the integral from a to b f of x dx. So for this particular problem, the average height of the tree on the interval 2 to 10, we're going to need to find the value of 1 over 10 minus 2, the integral from 2 to 10, h of t dt. H is not a function that they've given to us, and I also don't have a calculator, so I can't put this in my calculator. I can't actually do the calculus. What I need to do is read the question again, where they say using a trapezoidal sum. Remember, a trapezoid is going to look something like that. You have two bases, you have a height, the bases are parallel to each other, the height is perpendicular to the two, the area is found by 1/2 the sum of the bases times the height. If I were to plot these points, 2, 1.5, 3, 2, and let's actually do that. 2, 1.5, 3, 2, 5, 6, 7, 11, 10, 15. Not drawn to scale, I know. I'm going to approximate the area from 2 to 10 using these intervals that they gave us. I'm going to make my trapezoids. Here's trapezoid 1, 2, 3, 4. Again, not drawn to scale. For each of these trapezoids, I need to find the area. These sides here are your bases, so the length of each base is going to be determined by the y value. The height, the distance between those, is going to be the difference in the x values. So I've got 1 over 8. The integral from 2 to 10 is going to be 1/2. I need the height at t equals 2, which is, I've covered that up. Let me move that a little bit. Sorry. 1.5 plus the height at time 3, which is 2, times the distance between those two, which is 1, plus 1/2. We move on to the next interval. The height at 3 is 2, plus the height at 5 is 6, times the distance between those two, which is 2, plus 1/2. The next interval is from 5 to 7. The height at time 5 plus the height at time 7 times the distance between those two, plus the last one, 1/2, 11, plus 15 times 3. What is that equal to? I don't know. Clearly we could figure it out, but the fact is it doesn't matter. According to the College Board, if you work this out, you're going to get 263 over 32. What that is just a place where you are potentially going to lose points. So be careful. If this is the average height of the tree, you need units, so this is going to be meters. So the average height of the tree, which is what we're calculating here, 1 over 10 minus 2, the integral from 2 to 10 of h of t dt, is approximately 263 over 32 meters. Done. They awarded 1 point for everything that's in the brackets here. This is your trapezoidal approximation. 1 point for coming up with your approximation. There's no mention in the answer key of units, so I think even if you forgot to put the meters, you'd probably still earn the points, but why risk it? Put them in if you can. All right, last one, part D. Part D of this question. When I first solved this problem, it wasn't until the very end that I realized I had made a mistake and misread some of the information. So let's look at part D again. The height of the tree in meters can also be modeled by the function g, where g of x equals 100x divided by x, where x is the diameter of the base of the tree in meters. When the tree is 50 meters tall, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. According to the model, what is the rate of change of the height of the tree, rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? I realize I pretty much just went through and underlined every single part of this question. So let's tear this apart. Part D, they've given us a new function, g of x equals 100x divided by 1 plus x, where x is the diameter of the base of the tree. Okay, so x measures the diameter of the base of the tree in meters when the tree is 50 meters tall, and here is my mistake. When the tree is 50 meters tall, that doesn't mean that x is equal to 50 meters. The height of the tree, g, this means that g is equal to 50. When I filmed this earlier, I made the mistake and said that x was equal to 50. So what I know is that when the tree is 50 meters tall, at that moment, the diameter of the base of the tree is increasing at a rate of 0.03 meters per year. X is the diameter of the base, and the diameter of the base is increasing at a rate of 0.03 meters per year. So that's dx dt is 0.03 meters per year when g is equal to 50 meters. According to this model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? So what they're looking for is dg dt when big G equals 50. All right, so I want dg dt, the derivative of g with respect to t, when g is equal to 50. They've given me an equation for g. G is 100x divided by 1 plus x. I can find the derivative, but I need to find the derivative with respect to t. This means that it's a rate of change question. And so we're going to have to proceed very carefully, much more carefully than I did the first time. So here we go. I want dg dt, the derivative of g with respect to t. But I see that I have x as my variable. Well, dg dt, we're going to use the quotient rule, which is low 1 plus x times the derivative of the numerator. The derivative of 100x is 100 dx dt, right? Because we're taking the derivative with respect to time, and the derivative of 100 times x is 100 times dx dt. Minus, let's see, we did low d high, minus high 100x times the derivative of the denominator, which is going to be 1 dx dt, divided by 1 plus x squared. Low d high minus high d low, all over low low. Okay, good. We're doing well so far. Now I need to find the derivative of g with respect to t when g is equal to 50. The mistake I made earlier is I found the derivative of g with respect to t, but then everywhere I had an x, I replaced x with 50, but that was the mistake because g is equal to 50. I need to know what the x value is. So I need to do a little side work here. I know that g is equal to 50. So given the equation they gave me, that means that 50 equals 100x divided by 1 plus x. And I need to find the right value of x that makes this true. I can do a little bit of algebra here. I can multiply both sides by 1 plus x. That gives me 50 times 1 plus x on the left. On the right, the 1 plus x and the 1 plus x cancel out, and that leaves me 100x. Distributing the 50, we get 50 plus 100x equals 100x. Subtracting 50x from both sides, we get 50 equals 50x. And so that means that x has to be equal to 1. So when you want to know about when the height is equal to 50, that means that the diameter of the base is equal to 1. So if I want to know what is dg dt when the height of the tree is equal to 50 meters, everywhere I have an x, I'm going to replace 1. So we're going to get 1 plus 1, which is 2, times 100. dx dt at the time when the height of the tree is 50 meters is 0.03 minus 100, times x is equal to 1, times dx dt 0.03. Bad spacing there, sorry. Divided by 1 plus 1 squared. Simplify this if you want to, you don't have to. 2 times 100 is 200, times 0.03 is going to be 6. 100 times 1 is 100, times 0.03 is 3. 1 plus 1 is 2, 2 squared is 4. We get 3 over 4. And if I look carefully at the question that they asked, what did they ask? According to the model, what is the rate of change of the height of the tree with respect to time in meters per year at the time when the tree is 50 meters tall? So if you want to wrap this up and explain it in a sentence, what I would say is when the tree is 50 meters tall, the height of the tree is, let's see, this is a positive rate, so we're going to say is increasing at a rate of 3 over 4. What are the units? The units for the height is being measured in meters. The units for time is years. So this is being measured in meters per year. The way that they awarded the points, there are 2 points for coming up with an expression for dg dt, and then there was 1 point for coming up with the answer, which I would argue you get to the answer when you have 3 over 4 as your final answer. There was nothing that specified that you then needed to write the final answer in a complete sentence or including the units. So this is worth 3 points. And this is the fully correct answer to this problem. Hope that helps.